Hello there, this is Channel Mahendra Popat. We are discussing geotechnical engineering soil classification. Soil classification is the arrangement of soils into different groups such that the soils in a particular group have similar engineering properties and similar behavior. It is sort of labeling of soils with different labels. Why to classify soil or purposes of soil classification? Soil should be classified to arrange various types of soil into groups according to their engineering properties. To decide the suitability of a soil as a construction material for the construction of roads, earthen dams as well as embankments. To decide the suitability of a soil for the foundations of structures like heavy structures, as well as to provide a common understanding among different geotechnical engineers of different areas. The soil classification should be done. If we talk about basic requirements of soil classification, they are: the soil classification should be having a limited number of groups. It should be having scientific approach. It should be simple and should use the terms which are easily understood. It should have fair accuracy in indicating the portable performance of a soil under certain field conditions. It should be such as to permit classification of a soil by simple visual and manual tests. It should be acceptable as well to all the engineers, or say geotechnical engineers. So this is how the soil should be classified. Let us move forward. Field identification test. On field, we will do first test, which is preliminary or primary test. Then we will go to secondary test. In primary test, what is it? What is the procedure of preliminary or primary field identification test? The sample is first spread in the field on a flat surface. If more than 50% of the sample or more than 50% of the particles are visible to the naked eye, then the soil is coarse grained soil. If less than 50% of the soil particles are visible, then it is fine grained soils. In secondary testing, if they are coarse grained soil, we will do field identification as this procedure. If the soil is coarse grained, then I will check the size of particles. If they are greater than 4.75 mm, they will be gravels. If they are in between 4.75 to 0.75 mm, there will be sand size particles. If they are lesser than 75 microns, then they will be fine grained soils. But to differentiate fine sand from silt, we can do one test which is called dispersion test. When a spoonful of soil is poured into a jar full of water, fine sand settles in less than a minute or so. But silt takes 15 minutes, about 15 minutes to settle. That is how we will get to know it is sand or silt. If they are not coarse grained soil and they are fine grained soil, how to identify them? For that, there are 3-4 tests. Let us discuss. First test, dilatancy test. In this test, a small pat of moist soil of about 5 ml in volume is prepared. Water is added to make the soil soft but not sticky. The pat is placed in the open palm of one hand and shaken horizontally, striking against the other hand several times. During shaking and squeezing, motion in the palm. If the soil gives a positive reaction, the water appears on its surface, which changes to a lively consistency and appears glossy. When the pet is squeezed between the fingers, the water and gloss disappear from the surface. It becomes stiff and ultimately crumbles. The rapidity with which water appears on the surface during shaking and disappears during squeezing is used in the identification of fine-grained soil. The larger the size of particles, the quicker is the reaction. The reaction is called quick if water appears and disappears quickly. The reaction is called slow reaction if water appears and disappears slowly, and for no reaction the water does not appear at the surface. The next test, toughness test. In toughness test, the pad used in the dilatancy test is dried by working and remolding until it has the consistency of patty. The time required to dry the pad depends upon the plasticity of soil. The pad is rolled on a smooth surface or between the palms into a threads of about 3 mm in diameter. The thread is folded and re-rolled to reduce the water in soil due to evaporation by heat of hand until the 3 mm thread just crumbles. The water content at this stage is equal to the plastic limit, and the resistance to molding at that stage is called toughness. And the toughness test is all about that. After the thread crumbles, the pieces of the sample are lumped together and subjected to kneading until the lump also crumbles. The tougher the thread at the plastic limit and the stiffer the kneaded lump just before it crumbles, the higher is the toughness of soil. The toughness is low if the thread is weak and the soil mass cannot be lumped together when drier than plastic limit. The toughness is high when the lump can be molded drier than plastic limit and high pressure is required to roll the thread. In simple words, threads from cohesive soil of about 3 mm diameter, if they can be prepared, and as I have told before, it will be clay, and if cannot be prepared, it will be silt. The toughness depends upon the potency of colloidal clay. Going on further, dry strength test. Dry strength test is the pad of the soil is completely dried by air drying or oven drying. The dry strength is determined by breaking the dried pad and crumbling it between fingers in this. The dry strength is a measure of plasticity of the soil. The dry strength depends upon the colloidal fraction of the soil. Now let us go up to the feeling or the behavior of soil. If the dry pad can be easily powdered by fingers, then it is slight dry strength. If the dry pad cannot be powdered by fingers, then it is a medium dry strength. If the dry pad can be broken by pressure with palm or by palm, it is high dry strength. If the dry pad cannot be broken by pressure with palm, it is very high dry strength. So that is how we can know its dry strength is it slight, medium, high or very high. Let us go to next test, other tests. In other tests, there are too many miscellaneous tests which are very simple and basic. These tests can be felt by the feel only, the feel of that soil pad. Like if the feel of that soil pad is gritty, then it must be fine sand. If it is rough in the feeling, it is silt. If it is smooth, then it must be clay. If your fingers get stuck and doesn't get out easily by washing, it is wet clay. And if in case your fingers get stuck but get easily out by washing, then it must be wet silt. So this is how we can know how the soil is by field identification. On field, we can identify the soil by these ways, either if they are FGS or CGS. So here I conclude this video. In next video we will discuss further. Thank you.